PDC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PDC is inherited. About 75% of Italians can taste PTC. For example, you want to estimate the proportion of Americans who have at least one Italian grandparent and who can taste PTC. How large a sample must you test to estimate the proportion of PTC tasters within 0.04 with 90% confidence? Answer the question using 75% estimate as the guess value for the sample proportion. Okay, so the maximum margin of error is 0.04, 90% confidence interval, and our sample proportion is 0.75. All right, so let's try to find our corresponding z values for this. So we have 1 minus 0.90 divided by 2. That's going to be 0.05. So those are the areas that we want, those probabilities, right? So we have like 0.05, right? 0.05 and 0.05. And this here is 0.90, right? Now we got to find our corresponding z values to go with this, because remember, our inequality goes like this. Remember, it was z star times the square root of p hat. Let me make a little better p hat. P hat times 1 minus p hat all over n is less than or equal to the maximum margin of error, right? So we need to find these corresponding z's. So 0.05. So let's go to our table. So let's find our 0.05. So 0.0495 and 0.0505. So our corresponding z-score is going to be negative 1.6. So it's 0.05 and 0.04. So negative 1.645, right? So negative 1.645 and then a positive 1.645. All right, so that's our z value. And then we have our p hats and we have our maximum margin of error. So we use this inequality to solve for the n, the size of the sample, right? Okay, so this is 1.645 times the square root of p hat, which was 0.75, times 0.25, all over n, and that has to be less than or equal to 0.04, right? So now we're just going to use some algebra. So this is the same thing as the square root of 0.75 times 0.25 all over n less than or equal to 0.04 over 1.645. And now to get rid of this radical, we need to square both sides, right? So if we square both sides, that'll give us, so since n is positive, right, because n represents the number of people in the sample, that means this square root's only going to be taking the positive values. So this is going to be 0.75 times 0.25, positive, right, over n is less than or equal to, and we can rewrite this as 0.04 squared over 1.645 squared. And now we can do the inverse of both sides, so that way we can flip both fractions. But whenever we do that, we have to make sure to move the inequality. So this is going to be n over 0.75 times 0.25, right, is going to be bigger than or equal to 1.645 squared over 0.04 squared. And now, of course, we need to solve for n. So this gives us n is going to be bigger than or equal to, so I'm just going to rewrite this as 1.645 over 0.04 squared, and then times 0.75 times 0.25. And this implies that n has to be bigger than or equal to 3 317.11. So, of course, 317.11, there isn't 0.11 of a person, right? So, take an SRS of n is equal to 318 Americans with at least one Italian grandparent. Okay, so notice how we were able to use our inequality where we had the critical value, the z value, we had an estimate for our p hat, and we had our maximum margin of error. And from all that information, we got that we need a sample size of at least 318, right? And for future reference, so I'm going to write this inequality again. So note z star times the square root of p hat times 1 minus p hat all over n has to be less than or equal to the maximum margin of error. But let's go to our inequality that we had up here, right? So notice we were able to get n is bigger than, so from this in general, n is going to be bigger than or equal to, so 1.645 is that z star, and then 0.04 was that maximum margin of error squared, right? Times 0.75 is the proportion, the sample proportion, and then 0.25 was 1 minus p hat, right? So notice from this guy here, from this inequality, we're able to get this inequality to solve for n, right? So you can take a note of that whenever you deal with given the critical value, p hat, and the maximum margin of error, you can find the number and the sample size that would meet these conditions, right? And we're going to do that in part B. All right, so part B, answer the question in part A again, but this time use the conservative guess p hat is equal to 0.5. By how much do these two sample sizes differ? So, okay, so now we're going to use this inequality here to figure out the sample size needed when p hat is 0.5 instead of 0.75. So we'll have n has to be bigger than or equal to, so the z star is the same, so 1.645 over the maximum margin of error, which was 0.04, squared, and now p hat is 0.5, and that means 1 minus p hat would be 0.5, and this means that n must be bigger than or equal to 422.82. All right, so under this scenario, take an SRS of n is equal to, so 423, right? Americans with at least one Italian grandparent, right? And notice when we changed the sample proportion, right? Our sample size had to get bigger, right? So that's what we want to write down, right? Notice that in this case, the sample size needed is larger because the value p hat was 0.5 instead of instead of 0.75, right? So we can also say the sample size differed by, and then the second one, right? The bigger one was 423 minus, and then the first one we had to have was 318, right? So it differed by 105 people within the sample.